So these kinds of problems are very common on AP calculus tests. And I think the key is to not confuse the shape of f with the shape of g of x, because what you're seeing here, like especially in part A, like g of -1 has nothing to do with the value of f of -1, other than this first set of equations. So they're giving us 0 to x f of t dt, right? And that using x as one of your bounds is a pretty good indication that they want you to use the fundamental theorem of calculus. So if we take the derivative of the top, so d dx of the integral 0 to x, this becomes just f of x, right? So this is the fundamental theorem of calculus that tells us that the derivative of g is equal to the graph that's given. G double prime then is given as f prime of x, which is the slope of the graph that's given. So when we start looking at problems like A, right, we're given g of -1, right? Well, this is going to equal the integral from 0 to -1 of f of t dt, right? We want the bounds to go left to right, so we use our properties of integrals to switch the bounds from -1 to 0 of f of t dt. Right, and so this integral from -1 to 0 is going to be the area of this triangle. Right, so if you look at the area contained by the graph, right, the room between -1 and 0 forms this triangle, which has a base of 1 and a height of 3. Right, but we have to make sure that we take the negative of that, and this, right, is -3 over 2. G prime of -1 is f of -1, right? So we simply pull the y value off, and we get 0. And for the last part, g double prime of -1, we're looking at f prime of -1, which means we need the slope of the segment that's increasing. And if you look, the slope is up 3 over 1, so the answer to that part is 3. All right, so we look at the parts where g is increasing, and we'll look at that. So, part B, we're given, we want to know the intervals where g is increasing. And the other way to think about this is that g prime is positive, right? So those are interchangeable ideas. And from the first set of equations that we wrote, this is also a way of saying that f is positive, right? So if we look back at the original graph, and we look at where the graph is positive, that must occur between -1 and +1, right? And for what values in the open interval is it increasing, right? So we'll leave that. C, right, they're asking about where g is concave down, right? So if we're looking for g is concave down and we want to relate that to the derivatives, right, that means that g double prime is negative, right? And g double prime is negative means that f prime is negative. Again, based off of our first set of equations, right, we said that g double prime is equal to f prime of x. And g double f prime is negative is another way of saying that f is decreasing, right? And if we notice, it's increasing on the left side, and then after it hits 0, it starts decreasing. And so this occurs on the interval 0 to 2. The last part's the tricky part. In part D, we're trying to do the sketch of the curve, and it goes back to understanding the interaction between g prime and g double prime. So the first derivative tells us whether it's increasing or decreasing, and the second derivative tells us about the concavity. The way I like to do this is to look at basically have one row looking at g prime and the other row looking at not the values but rather the signs, right? So we know at -2 and -1, 1, and 2 things may change, right? We know that g prime is equal to f, right? And f prime is equal to g double prime. Now, if we remember the graph of f, it was under the x-axis for the region between -2 and 1, right? And then it's positive for the region between -1 and +1, and then it switches back to being negative from 1 to 2. G double prime is the equivalent of this slope, right, which is positive on the left half and then negative on the right half, right? And if we go back to look at the shapes of these curves when we're looking at the f prime and f double prime, positive, negative, f double prime, positive, negative, when we're on the smiley face, right, and it's increasing, it looks like this. When it's decreasing, it looks like this. Or if we're concave down and decreasing. And so you can just match up each of these combinations, right? So f prime, g prime is negative, but g double prime is positive, means our shape needs to be something like this. Right, and then it goes positive to positive, so it looks something like this. Positive to negative gives us this, and negative gives us the following. So this box, this 2x2, right, reference, it's really useful when you're trying to do these curve sketching problems because it gives you a good idea of what you need to do in order to give a general shape of the graph.